Now in this video we're going to focus on the derivative of inverse functions. Perhaps you have seen this formula in your textbook. The derivative of the inverse function with respect to x is 1 over the derivative. So looking at this formula, it might not always make sense. You might see it and wonder, what exactly does this mean? So here's a question for you. What is the inverse of x, or the inverse of the function with respect to x? What does that equal? Now it helps to understand what that equals. We know that y is equal to f of x. And if you want to find the inverse function, we need to switch x and y. So x is equal to f of y. Now what happens if we take the inverse function of what we have here? So if we take the inverse of x, if we take the inverse of both sides, the inverse function of f, they cancel, giving you y. So we could say that the inverse function with respect to x is equal to y. After switching x of y, of course. So therefore, we can replace this with y. So the derivative of the inverse function is also equal to 1 over the derivative of the function with respect to y. Now it's easier if you use this formula. I'm going to show you how to use it. So let's say that y is equal to x squared minus 7. The derivative with respect to x, this is also f of x, by the way. F of x is the same as y. The derivative is going to be 2x. What you want to do after you find the derivative is you want to switch x and y. So the derivative is 2y. Now using the formula, the derivative of the inverse function of x, we said it's 1 over f prime of y. So basically it's 1 over 2y. This is the answer. In terms of y, of course. Now let's say if we want it in terms of x. What should we replace y with? Now what you don't want to do is you don't want to replace y with x squared minus 7, because that's y for the original function. Rather, since this is the derivative of the inverse function, you need to switch x and y first. X is equal to y squared minus 7, and then let's solve for y. So if we add 7 to both sides, x plus 7 is equal to y squared, and if you take the square root, y is equal to radical x plus 7. So this is going to be the derivative in terms of x. This is the derivative of the inverse function. And if you want it in terms of y, this is it. Now there's two other ways we can get that same answer. So let's rewrite what we had here. We said that y was equal to x squared minus 7. This is for the original function. And y is also equal to the square root of x plus 7. This is for the inverse function. So I'm going to write this is f of x, the original function, and this is the inverse function. Now the second way in which you can get the answer, starting with this, is using implicit differentiation. So since we want to find the derivative of the inverse function, we need to switch x and y. So instead of having y equals x squared minus 7, it's going to be x is equal to y squared minus 7. At this point, after you switch x and y from the original function f of x, differentiate both sides with respect to x using implicit differentiation. The derivative of x is 1. The derivative of y squared is 2y times dy dx. For implicit differentiation, every time you differentiate a y variable, always add dy dx. The derivative of negative 7, which is a constant, is 0. So if you solve for dy dx, notice that we get 1 over 2y, which we had in the last example. Now, if you want the answer in terms of x as opposed to y, don't replace it with x squared minus 7. That's for the original function. We want to find the derivative of the inverse function. So replace y with the square root of x plus 7, because that's what y is equal to for the inverse function. So notice the answer we're going to get. 1 divided by the square root of x plus 7. So you can leave your answer like this in terms of y, or you can leave it in terms of x. It depends on what the problem wants you to do. So how can we know for sure that the two answers that we got previously, even though they agreed with each other, how do we know that they're correct? It turns out that there's a third method that we can use to find the derivative of the inverse function. And it's simple. Find the inverse function and take the derivative of it. So we found the inverse function already. We said that the inverse function with respect to x is the square root of x plus 7. We're going to ignore the plus or minus for now. But this is the inverse function. So all we got to do is differentiate the inverse function after we find it using algebra techniques. So the derivative of the inverse function is going to be, before we could find it, we need to modify this equation. Let's rewrite it as x plus 7 raised to the 1/2. So let's use the power rule. Let's take the 1/2, let's move it to the front. So it's 1/2 x plus 7, and we have to subtract the exponent by 1. 1 over 2 minus 1 is the same as 1 over 2 minus 2 over 2, and that's negative 1. Then you have to find the derivative of the inside according to the chain rule. The derivative of x is 1, and the derivative of 7 is a constant, so we could just ignore the 1. Let me write negative 1/2. 1/2 minus 2 over 2 is negative 1 over 2, so this should be negative 1/2. So let's rewrite it. We can write it like this: 1 over 2 x plus 7 to the positive 1/2. Whenever you move a variable from the top to the bottom, the exponent changes sign from negative to positive. So we can rewrite this as 1 over 2 square root x plus 7. Notice that we've confirmed our other two answers. This is the derivative of the inverse function with respect to x, which is what we had in the other example. Now we could put it back in terms of y. Now you need to be careful because x squared minus 7 is equal to y, but for the original function. But also the square root of x plus 7 is equal to y as well, but for the inverse function. So if you want to switch x and y, since you have the derivative of the inverse function, use this one because it's associated with the inverse function. Don't use this, it's not associated with the inverse function. So if we replace the square root of x plus 7 with y, we get the other answer in terms of y. We get 1 over 2y. So this part we can replace with y, and that's going to give us this. So now you have three ways in which you could find the derivative of the inverse function. One, here's the first method that we've used. You can find the derivative of f of x, the original function, and then just put it under 1 and switch x and y. And then that's going to be it. And then if you want to, you can replace y with x using the inverse function. Step 2, you can use implicit differentiation, or step 3, you could find the inverse function first and then simply take the derivative of it. So whichever method is easier depending on the problem, and that's the one you should use. To solidify the concept, we'll need to work on some more examples. So let's say if y is equal to x squared plus 2x plus 1. Go ahead and find the derivative of the inverse function in terms of y and in terms of x using all three methods. So using the first method, we know this is equal to the original function f of x. So let's find the first derivative. F prime of x, or y prime, is 2x plus 2. Now using the formula, the derivative of the inverse function is 1 over f prime of y. So we have f prime, which is 2x plus 2. All we need to do is switch x and y because we need to go from the regular function to the inverse function. So it's going to be 1 over 2y plus 2. So this is the answer in terms of y. Now let's see if we can get that same answer using implicit differentiation. So y is equal to x squared plus 2x plus 1. So this function is associated with the original function f of x. To do implicit differentiation, to find the inverse function that way, make sure you switch x and y. Once you do that, you move away from the original function f of x to the inverse function f negative 1 of x. Now at this point, we can find the derivative of both sides with respect to x. So the derivative of x is 1. The derivative of y squared is 2y times dy dx. Anytime you differentiate a y variable for implicit differentiation, always add dy dx. The derivative of 2y is 2, but times dy dx. And the derivative of 1 is simply 0. So now what we need to do is factor out the GCF, which is dy dx, times 2, but let's ignore the 2. Let's just take out dy dx. And so we'll be left with 2y plus 2. So now we need to divide both sides by 2y plus 2. And so we get the same answer as we had in the last example. So dy dx, the derivative of the inverse function with respect to y is 1 over 2y plus 2. Now let's get the derivative of the inverse function in terms of x, now that we have both answers in terms of y. So we know that y is equal to x squared plus 2x plus 1. But this is for the original function, f of x. So you don't want to replace y with x squared plus 2x plus 1 because this is for the inverse. The inverse and f of x, they don't match, they're different. So we got to find the inverse function first. Notice that we can factor x squared plus 2x plus 1. It's x plus 1 times x plus 1, which we can write as x plus 1 squared. So at this point, go ahead and find the inverse function. So the first thing we need to do is switch x and y. So x is equal to y plus 1 squared. Now we need to take the square root of both sides. So the square root of x is equal to y plus 1. So to solve for y, the square root of x minus 1 is y. Therefore, the inverse function with respect to x is equal to the square root of x minus 1, which is y for the inverse function. So at this point, what we want to do is we want to replace this y with the square root of x minus 1, because that's equal to y for the inverse function. Do not replace it with x squared plus 2x plus 1. That's y for f of x, not the inverse. So therefore, the derivative of the inverse function with respect to x is going to be 1 over 2, and then we could replace y with the square root of x minus 1. Has to be inside of parentheses, plus 2. Now let's simplify it. Let's distribute the 2. So it's 1 divided by 2 root x minus 2 plus 2. 2 times negative 1 is negative 2. So negative 2 plus 2 is 0. So therefore, the derivative of the inverse function with respect to x is 1 over 2 root x. Now let's confirm this answer using this equation. So what is the derivative of the square root of x minus 1? The first thing I would do is rewrite it. Radical x is the same as x to the 1/2. So let's use the power rule. Let's move the 1/2 to the front. So the derivative of the inverse function, this is the third technique, is 1/2 x to the minus 1/2. And the derivative of the constant is simply 0. So now let's move the x to the bottom. So this is 1 over 2 x to the positive 1/2, which is equal to 1 over 2 radical x. So notice that these two answers, they match. So using all three techniques, you can get the same answer. Now let's say if we want to find the slope of the tangent line at x equals 2. And so here's the original function. This is the one that's associated with f of x. How would you find the equation, the slope of the tangent line, rather than the equation at this point? The first thing I would do is find y when x is 2. So if we plug in 2, it's going to be 2 squared plus 2 times 2 plus 1. So that's going to be 4 plus 4 plus 1, which is 9. So we have the point 2 comma 9. X is 2, y is 9. And that's for the original function. Now let's find the slope of the tangent line at x equals 2, but for the inverse function. Now here's where you have to be careful. We have two formulas that we can use. We know the derivative of the inverse function in terms of y, it's 1 over 2y plus 2. But in terms of x, it's 1 over 2 square root of x. What should we plug in into the first equation? What should we replace y? What you do not want to do is replace it with 9. Because 9 is the y value for the original function f of x, not for the inverse function. The coordinates for the inverse function is 9 comma 2. It's different. So what you want to do is you want to plug in 2 for y. So basically you're using this value, but it's 2 is x for f of x, but it's y for the inverse of x. So you're still going to plug in 2, but you're not going to plug in 2 for x, you're going to plug in 2 for y. If you do that, it's going to be 1 over 2 times 2 plus 2, which is 1 over 4 plus 2, is 1 over 6. Now, you can always use this one too, but you need to use the x value, which is associated with the inverse function. So you have to use 9. Or you can use 9 for the y value of f of x. So for this x, you can plug in the x value that corresponds to the inverse function, or you can plug in the y value that corresponds to the original function f of x. So be careful with this. So either case, we got to plug in 9. So this is going to be 1 over 2 square root of 9, which is 2 times 3, and you get 1 over 6 again. Now there's another way in which we could find the slope of the tangent line. And that's by finding the average rate of change, which is the slope of the secant line, and using it to approximate the slope of the tangent line, which is associated with the instantaneous rate of change. So we know that the inverse function is the square root of x minus 1. Now we want to use this function because you want to find the slope of the tangent line at x equals 2. Now granted, at x equals 2, that is the x value for the original function. Now we can estimate the slope of the tangent line. It's approximately equal to the slope of the secant line when the 2 points converge to a certain value. The secant line contains 2 points. It is basically the slope of a line that passes through the curve at 2 points. The tangent line only touches the curve at 1 point. As these 2 points approach the red circle, the slope of the tangent line will become approximately equal to the slope of the secant line. The slope of the secant line is simply delta y over delta x. It's y2 minus y1 over x2 minus x1. Now the slope of the tangent line becomes approximately equal to the slope of the secant line when delta x approaches 0. Now keep in mind, for the inverse function, we have the points 9, 2. So we want to find the slope of the tangent line when x is 9 for the inverse function, which is the same as when y is 9 for the original function. So the slope of the tangent line is going to be f of b minus f of a over b minus a, when b minus a is very close to 0. So since this is in terms of x, we want to use the x value of the inverse function, which is 9. So I'm going to pick 2 points that are close to 9. Let's use 8 and 10, because 9 is the midpoint of 8 and 10. So we're going to find the slope of the secant line, which should be close to the slope of the tangent line. So this is going to be f of 10 minus f of 8 over 10 minus 8 using this function. So it's the square root of 10 minus 1 minus the square root of 8 minus 1 divided by 10 minus 8, which is 2. If you type this in, you should get 0.1669, which is close to our answer, 1 over 6. 1 over 6 is 0.16 repeated. It's like 0.166666, and you can round it to 7 if you want. Now, what's going to happen if we pick 2 points that are close to 9? So instead of using 8 and 10, let's use 8.9 and 9.1. So it's going to be f of 9.1 minus f of 8.9 over 9.1 minus 8.9. So it's the square root of 9.1 minus 1 minus the square root of 8.9 minus 1 divided by 0.2. That's 9.1 minus 8.9. If you type this in, you should get 0.166669. Notice that this is closer to 0.16 repeated, because these 2 points are closer to 9. So you're going to get the same answer, but the important thing is you don't want to plug in 2 into the derivative of the inverse function, because this 2 is the x value of f of x. Rather, you want to plug in 9 for the inverse function. So you have to switch x and y, and that's where it can be confusing, so watch out for that. Now let's say if y is equal to 2x to the 4th minus 3x cubed plus 5x plus 1. Go ahead and find the derivative of the inverse function. Now to do it, we can only find it in terms of y, not in terms of x. The reason being is we can't find the inverse function in terms of x. If you switch x and y, it is going to be very difficult to isolate y, to get it by itself. In the other 2 examples, we could have. One example we could factor and we got it in terms of y, but for this one, we can't isolate y, so we have to use the other techniques. So the first thing we're going to do is we're going to find f prime of x. The derivative is 8x cubed minus 9x squared plus 5. So now in terms of y, if we switch it, this is going to be 8y cubed minus 9y squared plus 5. So the derivative of the inverse function is 1 over f prime of y. So it's going to be 1 over 8y cubed minus 9y squared plus 5. Now let's get the same answer using implicit differentiation. So let's switch x and y. Now let's find the derivative of both sides with respect to x. So the derivative of x is 1. For 2y to the 4th, it's 8y to the 3rd times dy dx. And for 3y cubed, it's 9y squared times dy dx. And the derivative of 5y is 5 dy dx. And the derivative of 1 is 0. So let's factor dy dx out of the equation. So it's going to be 8y to the third minus 9y squared plus 5. So if we isolate dy dx, we could see that it's going to be 1 divided by 8y cubed minus 9y squared plus 5. So we get the same answer in terms of y, but we can't write our answer in terms of x, because we can't replace y with 2x to the fourth minus 3x cubed plus 5x plus 1. The reason why we can't do that is because this y is associated with f of x. We need the y that is associated with the inverse function. And since it's very difficult to isolate y for the inverse function, we don't want to do it that way. So we want to leave the derivative in terms of y for this problem. So now let's say if we want to find the slope of the tangent line at x equals 1, where this x value corresponds to f of x. What would you do? What I would do is find out the y value at this point using the original function. So if we plug in 1, it's going to be 2 minus 3 plus 5 plus 1. 2 minus 3 is negative 1, which cancels with the positive 1, so you get 5. So we have the point 1 comma 5 that corresponds to f of x. So what is the point that corresponds to the inverse function? So for the inverse function, we have the point 5 comma y. So the y value is 1, which is the x value of f of x. So basically, this point that you're given, you're going to use it anyway. You're just going to plug it into this equation. You just need to understand that at x equals 1 for f of x, y is equal to 1 for the inverse function, or for the derivative of the inverse function. So we're just going to take the x value for f of x and plug it in as y for the derivative of the inverse. So let's go ahead and get that answer. So it's going to be 1 divided by 8 times 1 cubed, which is simply 8, minus 9 plus 5. So that's 8 minus 9 is negative 1. Negative 1 plus 5 is 4. So the slope of the tangent line for the inverse function, where y is 1 for the inverse function, is 1/4. So that is it for this video. Hopefully this gave you a better understanding of finding the derivative of the inverse function and finding the slope of the tangent line. So that's all I got. Thanks for watching and have a great day.